Alright, so we need to write a formula in terms of theta, the central angle in radians, that could be used to find the length of an arc of a circle. So when we learned about arc length earlier, we used this formula. So like x degrees is the central angle measure, so like the same thing as theta right there, but this is in degrees. And we put it over 360 because that represented a full circle in degrees. Then we set it equal to the arc length and divided it by the circumference because those two things were proportional. Central angle in degrees over the whole circle in degrees is proportional to the length of the arc determined by that central angle. So if this was my central angle in degrees, then this is my arc length right here. Alright, and then circumference and 360 both represent the entire circle. So we're going to do the same thing, except we're going to change, instead of doing x in degrees, we'll call it theta for the central angle in radians. And since now like that's in radians, we shouldn't put it over 360 degrees, we should put it over a full circle in radians, which would be 2 pi. Okay, so I'm going to call arc length s because that's a common variable used for arc length. And circumference, we already know a formula for circumference, 2 pi r, which we could use, or we can use diameter times pi, but we're going to use 2 pi r. So if we cross multiply this, we get theta times 2 pi r equals 2 pi times s. So if we divide both sides by 2 pi r to isolate theta, we get theta equals s, the arc length, divided by r, the radius, which makes sense because that's the definition of an angle in radians. It's how many times the radius fits along the arc. So like if this is the radius here and this is the arc, theta just is how many times that yellow radius fits along that blue arc. So like if hypothetically if this radius was 2 inches and this arc was 6 inches, then this angle in radians would just be 3 because the radius, 2 inches, fits along that 6-inch arc 3 times. So we're going to use this formula now to finish the question. And the question says, use this formula to find the length of an arc of a circle with a radius of 4 inches and a central angle measure of 3 pi over 4 radians. Alright, so is theta, remember that has to be in radians, so that's the central angle in radians, equals s, the arc length, over r. So we know that the central angle is 3 pi over 4 radians, so I'll plug that in there. And the length of the arc is what we're looking for, and we know the radius is 4. So now if we solve this equation, we get s times 4 is equal to 4 times 3 pi. So you divide both sides by 4, you get s is equal to 3 pi. So just a quick recap, we get this formula just by using our original arc length formula, but instead of doing central angle over 360 equals arc length over circumference, we change that to central angle in radians over a whole circle, which we used that to represent, over the whole circle in radians, which was 2 pi instead of 360. Cross multiplied, got this formula, and then used the information here, plugged it in to solve for s.